Antje or Angie. In this third video, we're going to take a look at variables, constants, writing expressions, and some of the common student misconceptions associated with them. In many cases, students haven't really come across the concept of a variable before, and it can take them some time before they can sort of appreciate and fully understand that a variable can both take a specific value, like a equals 2, x equals 3, as well as be a placeholder for a whole set of values within a rule. So that's what we'll be looking at today. Let's use one of our patterns from the previous video to identify our variables and constants. Here is the pattern that we looked at where we're adding 2. We start with 1 stick, and then at the first term we have 3 sticks because we've added 2. Second term we've added another 2, so that's a total of 5 sticks, and so on. So we identified the rule for that pattern, which was the total number of sticks is 2 times the place in the sequence, which can also be the term, plus 1. So what in this rule is a variable and what is a constant? We would want students to know that S and P are variables because the place in the sequence and the number of sticks changes. We also want them to recognise that our constants are 2 and 1. For this pattern, they're constant because we start with 1 stick as our initial stick, and we are adding 2, and we have a constant pattern of adding 2. So these are our variables and constants. Sometimes people say, oh, variables can take any number, and I think that sometimes confuses students. In this instance, our variable can't take any number. Our variable can take 0 or any positive integer for place in sequence. The number of sticks, this variable, really only is representing positive integers because we can't start with 0 sticks. We're starting with 1 stick when the place in the sequence is 0. Can't be a negative integer, can't be a decimal number. So if we said any number is possible for P, some students then find that hard to fit together. So let's be specific about what values our variables can take, which also leads into this thinking that we want them to develop as they progress in their mathematics, where they start looking at domain and range and the type of values that a certain function might be able to take. The only other thing I want to point out here is that sometimes our constant of 1 here is called an initial or a starting value, and our constant of 2 here is also referred to as a coefficient, and that's because it's a number that multiplies a variable. Before we go on to expand and factorise some algebraic expressions. Before moving on to collecting like terms or factorising and expanding expressions, engage students in actually writing some expressions and understanding what they represent. It's a really good way to start doing this with some manipulatives. So one way to do this is to use pencil cases and pencils. In this case, my pencil cases are 4 identical pencil cases, all with the same number of pencils in them. We're going to have to use our imagination just a little bit. And we have sticks which are going to represent pencils. So our variable is let n be the number of pencils in a pencil case. Let t be the total number of pencils in the collection. And by collection, I mean the number of pencils I'm holding. So let's start. And this is what you would do with your students. I'm holding 1 pencil case. Write that as an expression. N or 1n, because the number of pencils in a pencil case is n, and that's the total number in the collection. Now write an expression for this. A pencil case plus 2 more pencils. We want to see students write n plus 2. Now this one they often struggle with a little bit more. Here's my pencil case, and I'm taking out 1, 2, 3, 4, 5 pencils. How many pencils am I holding up now? Give you a moment to think about that. The corresponding expression is n minus 5. So you can see how this is developing the understanding of a variable and then other actions acting on that. Now what about, I've put those 5 back in just so you know. What about if I hold up 3 pencil cases? How could I write that expression? Some students might write n plus n plus n, which is definitely correct. And of course we can write that also as 3 lots of n. And this might be a good time to discuss the convention that of course we have a multiplication sign between our number and our variable, so 3n stands for 3 times n. And while it's not incorrect to write n3, the convention is to put our numbers first and then our variables. All right, now I want you to write a slightly longer expression where you're going to write down and follow it with my actions. So I'm going to start with 1 pencil case. So we write down n. I'm going to take out 1, 2, 3, 4, 5 pencils. How does that impact the expression? It becomes minus 5. Let's assume that they're no longer here. Now I'm going to add another pencil case here. How is that dealt with in our expression? You write plus n. And then I'm going to pick up 2 additional pencils. So all in all, I've started with a pencil case, taken 5 pencils out of this one, added another pencil case, and then 2 more. So that is the expression that corresponds to that set of actions. And we can then simplify this to, we have 2n, minus 3. And of course we know we took 5 out of that, so we're 5 short, but then we have 2 more. So now we're only 3 short. So that is one way to develop students' understanding of writing expressions and putting some meaning to it. I would suggest that you do this over several lessons, number of times, 5 minutes, maybe for the warm-up of the lessons, until students become confident and fluent in writing expressions, particularly also with the negatives in there. Once they've established this, I like to go on to what I call step-by-step instruction. This is the sort of I think of a number scenario. So I think of a number and I'm going to ask you to write an expression as I say it out loud. Now I think of a number and I'm going to times it by 8 and add 13. How do I write that? Think of a number times 8 and add 13. So I would simplify that to 8n plus 13. I think of another number. I add 13 to it and then I multiply the total by 8. What would that look like? I think of a number, I add 13, and then I'm multiplying the total by 8. So I need to add my brackets, and then I get to times 8. So as you can see, order of operations are a big, they need to be known and understood when we're working with algebraic terms. And this is a really good opportunity to revise them. So negative numbers and order of operation are really, really important to make sure that your students have those and that they're reviewed. And this is one way that you can do that. So we have n plus 13 times 8, and that simplifies to, or normally gets rewritten as this. It's not actually simplified, it's more written in our standard form. I'm deliberately keeping the 8 and the 13 the same so that students are noticing the difference in the result of the expression and not worrying about the numbers. So this time, I think of a number and I divide it by 8, and then I add 13. And that is in its simplest form. And the last one, I think of a number, I add 13, and then I divide the total by 8. So in both these cases, there will be times when students, in this case, want to write this and put the 8 either just under the n or just under the 13. The same here, they actually may, if they don't know their order of operations, end up writing the first expression first. If you want students to see how different the order of operations is and the impact it has, ask students to substitute n equals 1 into each of these expressions and to calculate the result. And then that's a very meaningful way for them to see how different the result is and the impact that the order of our operations and our fractions has and the way that we say it. We do need to be precise about that. So once they've developed fluency with the concrete materials or manipulatives, then move on to step-by-step instructions and keep building those expressions so that students build up their meaning. Then next we will actually have a look at expanding and factorising and collecting like terms in the next video. So let's take a look at some of the common misconceptions students have about algebra and variables in particular. Why do you think referring to the expression 2b plus 3a as 2 bananas and 3 apples is problematic? I'll just give you a moment to think about that. So the reason that referring to 2b plus 3a as 2 bananas and 3 apples is that we're no longer treating b or a as a variable. We're treating it as an object, i.e. apple and banana. And in this example, b and a can only ever equal 1, so it's not a variable. The expression actually represents 2 times an unknown number of bananas and 2 times an unknown number of apples. So you can see that's quite different, and now the number of bananas and apples can change, and it's the lots of and how many of those we have that stays the same. This is sometimes called interpreting variables as letter as object misconception, and is also often referred to as fruit salad algebra, which is not what we want to be doing with our students. So how can we mitigate this and avoid students having this misconception? Well, one of the things is what I was referring to in the growing patterns, that we actually have number of bananas and number of apples in words to start with, and then move to the symbolic notation later. Another useful thing is not to use the letters associated with the objects. So rather than A and B, let's go with N or M. That way students are less likely to make that connection, and this is actually being confirmed through research. The other really useful thing is that we want our students to define each variable. and to actually write down what is the variable and what does it stand for. This is particularly important in the early stages while they're consolidating their understanding. So as you can see here, we've said let n equal the number of bananas, let m equal the number of apples. And in that way you can see that all of this is about keeping the focus on the number of, the position in. And I think as teachers we also need to make sure that we're modelling that in our teaching and always referring to it in that correct way. So it's quite useful to know, why do students have this tendency to want to name a variable or think of it as an object? And some of this might come from the types of problems that they do in primary school. In primary school, students do spend a lot of time solving for one specific number, or maybe a pair of numbers as shown in this example. So I think it's helpful to understand that, you know, it makes sense that initially they're going to view a variable as more of an object because that's where they've come from. So being aware of that might help how you explain and frame and just, you know, what a variable is. Now there are a couple of other sort of common misconceptions or understandings to look out for with your students. And some of that is algebraic convention, and again, some of it is maybe what the way they've been working previously. So as we can see here, 5n actually is referring to 5 times n, or 5 lots of n. And 5ny means 5 multiplied by n multiplied by y. Now sometimes students won't realise or just forget that there is that multiplication sign sitting between those, that it's 5 lots of n, and will actually, if they see 5n and n equals 8, slot it in as making the number 58 rather than seeing it as a multiplication. And another thing to look out for is that if students are simplifying an expression, and let's say the answer results in 3x plus 7, they can feel pretty uncomfortable leaving that as an answer because it might seem quite foreign to them that that is an answer. It's got an addition sign in it, so they want to do something. It just doesn't feel complete. So they really do need a lot of examples, and it's worth explicitly pointing out that in algebra, this is the complete answer and it can't be simplified any further. All right, so now it's your turn to have a little turn. Write an equation or expression that represents each of the following. I'll just give you a moment to do that. All right, now I want you to write an incorrect answer that students might give to exactly the same situations. I'll give you a moment to answer that. So probably what you've come up with is that the correct answer is student equals 8 multiplied by a, or our number of students is equal to 8 times the number of adults. But very often, particularly while students might still be thinking of variables as objects, they will associate the 8 with the student because it's also how they're reading it. So in that case, it is really, really important that every time students are developing and writing an equation, that they substitute in a pair of numbers that they know works and makes sense in that situation. And you might recall that we did that with the growing patterns in video 2 as well. So in this case, if I say, well, if I have 2 adults, I expect to have 16 students. So if I do substitute in 2 for adults and then I get 16, I can see, I've validated this is the correct rule. Whereas if I substitute 2 adults and 16 for students, that is not going to give us a ratio of 1 to 8 because we'll end up with 8 times 16 students here on the left. So here we have the expression A is subtracted from B. Again, a common error is that we are writing it as we're reading it, as you do in a sentence. So the correct answer is B take A, and the incorrect one is A take B. This is a little bit harder to sort out with substitution because we don't have that next bit in terms of the answer that we're anticipating. So these are all things to keep an eye out for. So in conclusion to this video, I guess I really want to highlight that a lot of the misconceptions and common errors that we've discussed can be mitigated if we spend that time developing that background and foundational understanding as we did in the first two videos and in this one as well. That way students have written algebraic expressions, they've written general rules for patterns, and they're making that transition of understanding that the variable can both be a specific value and a placeholder for a set of values for a specific pattern or rule. Thank you.